My name is Bob Foreman, as Christina had already mentioned, and I am a senior software engineer at LexisNexis Risk Solutions. I'm going to talk to you today for a short talk about HPCC Systems, the kit and caboodle for big data and data science. Now, it's kind of a strange name for a title of a presentation, kit and caboodle, but one of my colleagues had mentioned it one time before, and I kind of liked it because the meaning of the word kit and caboodle means the whole package. And HPCC Systems as a big data and data science solution is, in my opinion, the full package. I'm going to show you that in the next 20 minutes. So HPCC Systems provides end-to-end data lake management. And here's the good news. It's completely free. All of the binaries to install the cluster software, all of the support tools, the documentation, all of that is free on our HPCC Systems portal. Also, out-of-the-box capabilities, it's fairly easy to use. It's got good documentation. The language that supports HPCC Systems is a language I've been teaching for the last 11 years. And it's an easy-to-use language. It's a declarative language that is dedicated to be data-centric for big data. So it involves less coding. We invented that language called ECL, the Enterprise Control Language, to allow you to code less and get more results. So once again, a one-stop website portal to download all of the software that you need to build your own HPCC Systems cluster and get to work with your big data needs and analytical needs. Now, also, we are in the middle of our 10-year anniversary. We began it last June of 2021, and we are still 10 years and counting. We'll have our 11-year anniversary this June. So we're celebrating our 10-year open source anniversary, and that means a lot of other goodies and benefits that I'm going to talk about at the end of this presentation. So why does HPCC Systems exist? And I apologize, let me explain what HPCC stands for. It stands for High Performance Computing Cluster. So many years ago, we came up with the idea that distributing data in a parallel platform in a variety of different configurations was actually more efficient and faster to work with large amounts of data than working with a single server, a client server platform, and so on. So we developed this technology, first of all, for ourselves. We didn't really want to sell it or market it to anybody else. We developed this technology to solve our own big data problems. So it was kind of interesting. We began this process of working with large amounts of data, and we had one of our clients approach us many years ago, and they had this problem. They were working with an algorithm with bankruptcy prediction, and they were using SQL on a mainframe. And well, after about 60 days of a proof of concept, we pointed them to HPCC Systems and our underlying ECL language. And what took them 26 days to run a bankruptcy predictive report was reduced to, listen very carefully, 6 minutes. So anyway, that got us started on HPCC. We knew we had a winner, and we started marketing it for our own products and services to our customers. We are part of LexisNexis. LexisNexis owns the technology for HPCC Systems, but we are open source, and the technology is absolutely free to the community. Once again, HPCC, I like to define it as a distributed data parallel processing platform. So we are everywhere in industry, any industry that works with large amounts of data. Again, this slide, I won't bore you with it, but really the reality of this is if you go out to our LexisNexis site for our products and services, you'll see that we have industries for collections and recovery, financial services, government, healthcare, insurance, law enforcement, public safety, and corporations and nonprofit groups. So it's a processing platform that brings your data together across all verticals. Little timeline history here. Back in 2001, the original version of HPCC Systems was released, but back then it was proprietary. But yes, it's been around for 21, 22 years now. Actually, it was conceived in 1999, and the first implementation of it was 2001. In 2011, we said, hello, community, let's go open source. And so we open sourced our platform, made it available. It was kind of a soft launch. We debuted the website and opened it to the community. In the years that followed between 2012, 2016, we listened to the community, we got feedback from the community, and we worked on more additions to the HPCC Systems platform. And you know what the biggest changes were making the cluster give you more connectivity to other platforms that the community was already familiar with, like Python, JSON, Java, Spark, and so on. So we started to make connectors and plugins to HPCC systems so you can interact with other systems with the HPCC data lake. And now in 2017 up to the present, we are still working on improving our architecture, more IoT support, more bundles in machine learning and other big data analytical disciplines, and also a big move to the cloud. So we have going on right now a movement of moving from bare metal clusters to using the cloud platform like Microsoft Azure. And it's not just a lift and shift that we're doing, it's a complete redesign of the HPCC systems to use containerized approaches to our big data clusters using things like Kubernetes and Helm and Docker Desktop. All right, so we knew a long time ago that a single source of data has problems. It has, it's inefficient, missing data, inaccuracies, and so on. So we knew also that also working with large amounts of data, that we wanted to have data from multiple sources. So that's what we essentially do with HPCC. We have a data lake of different data sources that we ingest, clean, we then standardize, and then link into common formats, common record structures that we talk about, where we are then working with actionable smart data that we then later on index and deliver to our customers. Dan Camper talked a little bit about indexes in his talk earlier this morning regarding fuzzy matching. Now you can test and run an HPCC systems right from your desktop or laptop machine. We have support for the Oracle VirtualBox virtual machine, HPCC VM, but we also now support the creation of a Kubernetes localized container cluster using Docker Desktop. And so all that information is out there on our portal, the documentation. I actually have a video lesson that I put together that shows you how easy it is to set up a cluster in minutes locally on your own laptop. Now, in the real world, of course, when you're working with a lot of data, we, of course, have multiple servers working as a single processing entity. And so that's the way that we work with in our day-to-day operations. Now, on the left side here, your local clusters use Oracle VirtualBox, virtual machine, also Kubernetes and Docker Desktop. On the right side here, we have hard metal data centers still in place in our data centers in South Florida, in Georgia, also in Ohio, and also around the world. And then we have our cloud initiative using AWS or Microsoft Azure, working with Kubernetes. So this slide just talks about the concept of working with big data, reducing it to a smaller data form, and then analyzing, computing it. There's not much to say about this slide. We'll move on to the next one. This is the cool slide I like. This is the full picture of HPCC systems. On the left side of this slide, you see big data coming in structured, unstructured, or semi-structured formats. It gets ingested, imported, or the term we like to use is called sprayed to the Thor cluster. The Thor cluster is our data refinery, our data factory that does all of the heavy lifting of large amounts of data, everything from cleaning to standardizing, to linking, and fusing the data into common groups of information that is then valuable to our customer. That information that we process in Thor then gets published to the ROXIE cluster, and the ROXIE cluster is dedicated for data delivery. Underlying the whole thing in HPCC is our programming language called ECL. ECL is the Enterprise Control Language. And also supporting with the ECL is our machine learning libraries, data management, and much, much more. Also on the left side in the lower left-hand corner is how you work with the cluster. We have a flagship ECL IDE that's been in place for long over 15 years. We have, recently, since 2018, now we have support for an ECL extension embedded in Visual Studio Code. There's also a cloud IDE that we use for workshops and hackathons that is a cloud-based web service IDE. And then also CLI, command line interface, where you can just avoid IDEs if you don't like them and just run all of your jobs on your command line. So in summary, Thor, the data refinery cluster, can extract, load, cleanse, transform, link, index, all that, all the heavy lifting is done on Thor. ROXIE was a cluster, again, parallel processing of our information that allows us to distribute the data to our customers in sub-second response time. And actually it's concurrent, so you can have multiple customers querying the cluster at the same time. In a typical 100 node ROXIE production cluster, there are 30 threads per node, so you can have actually 30,000 queries happening. And with sub-second time, you can have performance that is, the average query is about 1/4 of a second. Data management tools, you've got data profiling, cleansing, all of that is built in and supported through a group of libraries that are automatically bundled when you install the either IDE, your Visual Studio IDE or your ECL IDE. And then also along with that, the machine learning library. We'll take a look at more of those later. On our website, you'll see a front page, and this is one of our graphics that we have when you come in. It's called the Data Lake solution. So once again, we ingest multiple types of raw data. They can also be batch, real-time, or streaming ingestion. We then have our open source data lake. We like to call it data wrangling, where we're cleaning it and deduping it and linking it to other entities already in our lake, and then also applying analytics using machine learning and other tools. And then finally, the single glass of water information delivery to our customers. So it's scalable to petabytes of data, runs on commodity hardware. We call that COATS, commercial off-the-shelf hardware. That's the other thing too. HPCC Systems doesn't rely on special servers, hardware. It's the software that controls the operation. So just regular commodity hardware, it's very cost effective. So the Thor cluster is responsible for profiling, cleansing, transformation of data from one form to another, and then of course analytics. It manages data more quickly and efficiently. Our ROXIE cluster is our data delivery side of things. Now, I like to do this in my training classes. I like to talk about Thor and ROXIE kind of like the like a big data McDonald's. If you were to walk into McDonald's, you walk in, you come up to the counter, you place your order. The counter person says, "Do you want to supersize that? Do you want to drink with that?" By the time you've made your order, it's almost there. By the time you pull your wallet out to pay, the order is just about ready for you. Meanwhile, you're looking behind the counter and you see behind the lights, you see people running around doing crazy things in the background, dropping fries, flipping burgers, and so on. I like to look at the counter person as being our ROXIE cluster, delivering the data to the end user. And behind the lights, the grill is Thor, processing the data, getting all of the food ready to serve, and then again, providing an individual order to a customer who requests it. The ROXIE cluster has a number of interfaces like JSON, XML, representational state transfer, and of course SQL. Now we're getting into my comfort zone. We talk about the language that is behind the scenes with HPCC. This is called the Enterprise Control Language. This language was designed to be data-centric. It is more, well, it's declarative, so you tell ECL what data you want and not how to get there. So in other standard languages, you might have like a loop construct, and you say loop from the beginning of the file to the end of file, test each record. If the record meets a criteria, go get it, perform some kind of operation, put it back into the data set, and then move on until you get to the end of the file or until you got some break logic. Well, ECL is designed to do all of that for you by just simple transform functions like project, iterate, even simple queries. Will loop through an entire data set. You have some very powerful filtering built into the language, and it's kind of easy to read and understand. If you look at this right now, they're talking about some machine learning stuff that's doing some kind of distribution, and there's an if condition there that's looking for the existence of a parameter. If the parameter doesn't exist, it only passes 2 parameters. Otherwise, it's passing 3 parameters to this machine learning distribution algorithm and generating data behind it. So ECL is, again, what data do you need and not how to get there. It's built in and was made for HPCC systems. So it's transparent and it's implicitly parallel in line with the parallel processing of HPCC. Powerful and flexible, fast, accurate, and it's optimized, again, for data-intensive operations. And I think the syntax is pretty intuitive. Now, here's the tools that you have to work with HPCC. First of all, the flagship product that we've had out for years is called the ECL IDE. It's a Windows-based IDE based on the .NET framework. It's been around for a long time. It's got a repository on the left side where all of your code exists. It's got the work area there. You've got any syntax errors or information that's shown at the bottom, and a lot of other bells and whistles. New, but now kind of the new kid on the block, but also the hot IDE, the one that a lot of people are using is the VS Code. And it says here for Unix and Mac OS or Linux and Mac OS, but you can also use it for Windows as well. So you install VS Code for the appropriate platform. You install the ECL language extension. You use the launch.json file to connect to your cluster, and you're off and running. And we also have a command line interface as well, okay, which is ECL.exe under the command line. Now, the ECL IDE allows you to write queries, get instant results, instant gratification through the IDE. You can build definitions, which you can then reuse in other ECL work units. And that's pretty much it. Another tool that you have behind it is the ECL Watch. This is a web-based tool that lets you see how your cluster is behaving. You can see what jobs are running. This is the front page. This is called the activity page. You've got other areas of the ECL Watch to monitor your ECL work units, to monitor the data, to look at what data files are on the cluster, and to monitor the cluster health. Here's a sneak peek at our new ECL Watch, which is going to be coming up in version 9 in the next upcoming weeks. And you see the interface has just been more streamlined. All of the features are there and much more. Namely, we're starting to migrate to be more cloud-oriented. So when you run a job now in the new ECL Watch, you'll see there's a couple of blocks in here that says execution cost and file access cost and so on, which can then monitor the cost of doing business on your cluster. So with the ECL Watch, again, you can see active work units, you can monitor cluster activity, browse work units, look at files, record counts, sample records, and so on, and also the very important log files. And also stop and start processes that are currently running on your cluster. Here's a slide on how we take data from the outside world and put it onto a distributed cluster. The file formats that we support can be fixed, delimited, variable IBM format, XML files, JSON files. We try to deal with any file that is out there in the world. We can import it into the cluster. Using the ECL Watch as a tool to import, you can use ECL language, calling one of our libraries, or you can even use the command line. We take a single file on our landing zone and we divide it into physical parts that are then distributed evenly across your target cluster based on the number of nodes. And here's the beautiful thing. Once you distribute it in your ECL code, you treat the distributed data as a single logical file name. So whether you're using a 3-node cluster or a 10-node cluster or a 15-node cluster, it's treated as a single file. All right, so this slide here is just another summary of HPCC systems, from integration to profiling to cleansing, standardization. The funnel here is Thor. The sweet spot here on the right side is the delivery to ROXIE. And you can see this in the PDF and study this. Again, it's pretty much the same thing as a previous slide that I showed. So to wrap this up, we talk also about the other support with HPCC. We have profiling tools that are built into the cluster, libraries that actually produce a full, rich data pattern report on any file that you have ingested into the cluster, including things like fill rates and cardinality, numeric range detail, and so on. This is all built into the platform automatically. Also, our machine learning library, very rich. You remember, I think Dan had talked about this morning, the Levenstein deletion neighborhood. We've got a number of algorithms and things that are bundled in the machine learning library. Some of these are already published and ready to go. Some of these are in the development stage, but this is kind of our menu of what we're supporting in the machine learning world. Also, visualization is a big thing. We're supporting visualization where built in, there's probably 3 or 4 different ways that you can visualize your data and then incorporate it in your work unit results. There's a visualization bundle. There's built-in visualization in the ECL Watch, and you can call the visualization a number of charts and graphs via the library. Finally, we'll talk about the plugins and libraries. There are many here that if you are a Spark guy or a Kafka person or a Couchbase individual, Pentaho, Tableau, all of these are plugins that are available for you to connect to the HPCC data and interchange it with these different external platforms. Embedded language support. So if you are good with C++ and R and Python and Java, Cassandra, SQL, and there's a few more scripting languages I haven't listed here, this is how easy it is to embed languages into HPCC systems. So this is showing here a couple of examples of embedding Python, embedding Java. Essentially, it just works with an import statement and an embed structure, and you're good to go. You can then, through ECL, attach to external languages as needed. All right, so in summary, HPCC Systems, we believe, is an end-to-end data lake management solution. It's mature. It's been around for 22 years, heavily used in commercial applications for almost 2 decades, as I just mentioned. LexisNexis Risk Solutions uses it for a variety of their products, and we've been open source so you can use it for over now going on 11 years. It's powerful, versatile to work with, and you can manipulate your data as needed. Your clients will love it. It's fast, easy, and accurate. So in summary, I like to call it the kit and caboodle for your big data and data science solutions. So that's all I have. Thank you very much for listening. And I know it was kind of fast. I wanted to just give you a little 30,000 view overview. Please visit our HPCC Systems website for more information, documentation, downloads, free online training. And we have a special right now this year in our 10-year anniversary. Everybody who wants to learn about ECL and HPCC, our introductory classes have always been free, but All of our advanced classes and our machine learning classes and other courses that we have available are also now free for a limited time this year as we celebrate our 10-year anniversary. So check us out. Go out to our, either contact me or contact us at training@hpccsystems.com. And lastly, if you want to try out a cluster, we have a cluster here called play.hpccsystems.com with a port 8010, and it is an actual public cluster available throughout the world. You can spray some sample data out there. Remember, it's a public cluster, so don't spray any sensitive personal information out there. But if you have any sample data out there and you want to play around with the ECL language or see how the cluster works, you're more than welcome to do that. So that's all I have on my side of things. Thank you to everybody for sticking around and listening. And I'll see if there's any questions. Anyone have any questions or anything that is popping up in our, let's see, what do we have here? I don't see anything.
Many thanks, Rob. Yeah, we do have a question in our Q&A channel. We have a question from Hamid. He's asking, is ROXIE like a data product as in data mesh?
Well, it's ROXIE is a data delivery system where we build indexes in Thor that are nothing more than special data sets that have search information built into those data sets. In those data sets, they're ISAM files. They contain a meta key that allows for very fast searching. We've used this technology, like I said, for about 20 years and counting. And by the way, HPCC and ECL is a dynamic product. There's always improvements with every release. ROXIE gets faster, Thor gets better, and so on. Similar to data mesh, I think it'd be like apples and oranges there. The way it works is, like I said, in Thor, you process these indexes, then you publish them to ROXIE, they get distributed. A single node on ROXIE then receives a query from the end user. In the meta key that's built into these indexes, it knows what data to go search for on a particular data channel, and then returns it back to the server agent, and then returns it back to the request store.
Okay, thanks a lot.
Yes, well, yes, there's all kinds. There are connectors to SQL. We have a tool called WSSQL, which allows you to write SQL statements and then have those SQL statements converted into ECL format. So you have that. You have embedded support with MySQL and other types of SQL scripting languages, and you can embed the SQL directly in your ECL work unit.